Okay, so we were doing on the back page, the bottom left problem. So I'm going to tell you again what I did. So method 2 says, first of all, write your inverse function. So you change y to x, all the x's to y's. This is the inverse function. And then we're supposed to do the derivative of this. So I did the derivative of x is 1. Then I did power rule. I got 10y to the fourth y prime and 3y squared y prime. And 1 is 0, so you don't worry about the 1. And y prime is the same as dy dx, so you can write it either way. And then I solved this. I factored out y prime and then solved this for y. We'll solve y prime to equal this. And again, you need to know this is the inverse. So this y prime is the inverse of f, the derivative of the inverse of f of x. Then next step says plug k in. Well, k is this 4 value they give you, and they say plug that into this function. And then we have, so we put a 4 in for x, and we're supposed to solve this with no calculator. That's where we were. So what we're going to know now is if they say no calculator, that means the answer to that is an easy answer. In other words, it's going to be an integer probably. All right? So I'm going to show you what you can do is just start guessing. But I'm going to show you what we can do from pre-cal days and from algebra 2. You can set this equal to 0 by subtracting 3. I'm sorry, subtracting 4, and 1 minus 4 gives you negative 3. Now from algebra 2 and pre-calculus, these are called p factors. The factors of 3 are your p factors, and the only factors of 3 are 1 and 3. 1 times 3 is 3, that's it. And this is your q factor, the number in front of the leading coefficient. And your only factors of 2 are 1 and 2. And we did p over q's. You guys remember that from algebra 2? Those are all the possible rational zeros. So p over q's are all the possible factors. So you put 1 and 3 over 1, and you put plus minus and plus minus. And then you go back and you put 1 and 3 over 2, so you get plus minus a half, plus minus 3 halves. Those are all the possible rational factors. Now, like I said earlier, if it says you don't need a calculator, you can just start plugging these in and see what works. So let's plug 1 in and see if 1 works. So if I plug 1 in here, 1 to the 5th is 1. 2 times 1 is 2. 1 to the 3rd is 1. And plus 1, does that right there equal 4? So that tells me y equals 1 is the answer I'm looking for. You see what I did there? Now the reason the p over q's help is I know that 2 won't work, so I wouldn't try 2. Now, if 1 didn't work, I probably would have tried negative 1 next. I hope we can see that negative 1 gives me negative plus, right? So that'd be negative 2, doesn't work, right? So if it doesn't work, you got to try a different one. So we get y is 1. Now, the last thing we do is we're supposed to plug this y of 1 in over here for this function to actually get the value. So we are going to get that because the inverse means that the y value from this is the x value over there. So when we plug in this 4, we're doing the inverse derivative of the inverse for 4 by plugging that 4 in. That is going to equal, I should probably say that I'm going to let y be 1 there. I'm plugging 1 into this thing. I'm going to get 10 times 1 to the 4th plus 3 times 1 to the 2nd, which ends up being 1/13 when you simplify it. Okay, that's method 2. Now, you could have also done this on your calculator, this part up here at the top, 4 equals 2y to the 5th plus y cubed plus 1, if you do it the same way I showed you on the video, okay? The video I posted today. But this says no calculator. And this stuff is not on the AP test a whole lot. There's usually one problem in multiple choice, either off of this section or 3-4. Now they'll probably put 10 on this year. I don't think so, but who knows? Anybody else got anything you want to see off this? Okay, we want to go over some questions on 3-4? Hello? Yeah.
Can I go over the top left?
Of this page?
Yeah.
All right, let's do the top left. Okay, now this says, it's got this picture, so we must use a calculator on this one. And since it doesn't say which way to do it, I'm going to use my favorite way. And my favorite way is to use the formula. And the formula says this, that the derivative of the inverse of x is going to be 1 over f prime of the inverse of f of x. That is the formula. This is method 3 on your notes. So what this says is I'm going to use x as 3. So what that means is I'm actually putting a 3 in here, and I'm putting a 3 in here. That's what I'm doing. So what I want to do is find the inverse when f the inverse of f when x is 3 into the inverse. So I'm going to do the inverse again. So I'm going to get x equals y over 2 plus, I'm going to write this like this because this is how you have to type it in your calculator, like that. And the thing I'm going to plug in here is going to be 3. I'm taking that 3 and plugging it in here. So I'm going to do my calculator. So this is what you're going to see if you watch the other video. Only I'm going to do it a little faster this time. And again, you can go back and watch this if you wish. Did you guys write down what I just had up there?
Yeah.
Okay, so wasn't it y equals 3? 3 was on one side, right?
Yeah.
Okay, so I put the 3 there, and what was the other equation?
Y over 2 plus sine y.
Y over 2 plus sine y. All right, we can't put y's in here because it's got y's 2 equals, so we're going to use x. So we're going to put x over 2 plus sine x. Now, what we got to remember is, what we need to remember is that this x is really a y for up here. Yeah. Okay, so I got to put sine in parentheses, so I'm going to. So you got to put sine x in parentheses and, let me zoom in so you can see. So I put those two in there, but I have to use x because on this problem and this calculator, you can't use y for y's. It won't work because you got y's on the other side. Okay, so I'm going to graph this. So there's my y equals 3, and here comes my funky function. So the value of y I'm looking for, now to me it looks like it might have hit twice. Do you see that? So I'm going to show you that it doesn't. I'm going to hit zoom 2, or yeah, zoom 2 is zoom in. And if my cursor's at 0, 0, I'm going to move it over there by those intersections, and I'm going to zoom in. I'm going to zoom in right there so we can see that part better. There's probably, should only intersect once, I hope. Yeah, so there you can see the space between there, right? So I want to find that intersection over there in that blue line. So I'm going to hit second, calc, 5. That's intersect. And they say, is that the first line? Yes. Is that the other line? Yes. And I hit enter a third time, and here's my answer. So the answer to this is 4.30866611. Now, I'm going to do this differently than I did the first video. Your calculator right now has that number stored in X. In the X value, that number is stored by your calculator. In the last problem, I showed you how to store that number in Y. So you're going to want to learn how to use that store button. But this is in X right now. So what I can do is, I can now go, that's the value I want for my inverse function. I'm tempted to show you a new thing on here. So let me get this screen off so I can see the original problem over here. So what that means is I got y, oh shoot. What was it? Did anybody write that decimal down? I got it on my calculator. I'm just going to hit x by alpha. Oops, shoot. Let me show you this. I'm going to hit second quit. I'm just going to show you. I'll move the stupid thing over here. I want to show you that x is the same, that decimal number we just had is still in for my x. So I'm going to quit this screen, hit second quit. And then I'm going to hit X, I'm going to hit enter, and there's that decimal. See, it's in the X right now. Okay, so that decimal number's in there. So what I'm going to do is I'm going to use that in place. I'm going to use that in place to figure out what this thing is. So in other words, I will try to finish this problem later. I'll come around and spray. My bad.